Okay, I think we can start. So hello everyone and welcome to the 5th lecture of the Current Topics in Heritage Science series of Hyperion HS Academy. This series is organized by emerging professionals in the frame of the Hyperion HS project and the European Research Infrastructure for Heritage Science. My name is Diego Quintero. I'm a postdoc at the National Institute of Optics in Florence, and I'll be moderating today's lecture. Our topic today is radiocarbon dating and its impact in the study of human evolution. The recording of this lecture will be available later on the E-RIHS YouTube channel, and at the end of the lecture you will receive a survey. Please take a few seconds to let us know your opinion, and be aware that the attendance confirmation of this lecture will be released after the survey submission. You can ask questions through the Q&A function at the bottom bar of the Zoom window, and if you experience any technical difficulties, you can contact us using the chat. So today is my pleasure to present our speaker, Professor Sahra Talamo. She is full professor in chemistry with a special interest in studying human evolutionary events in combination with radiocarbon dating. During her period at the Max Planck Institute of Evolutionary Anthropology, she has developed outstanding expertise in human evolution research, particularly regarding high-resolution chronologies in the study of human evolution and geosciences in glacial times, with strong competence in interdisciplinary collaboration. In 2018, she won an ERC starting grant called Resolution, which started on June 1st, 2019. In that project, she will develop high-resolution radiocarbon calibration datasets using fossil trees to gain resolution, precision, and confidence intervals to resolve key periods in European prehistory. The results of this project are of pivotal importance to precisely establish the time of the arrival of Homo sapiens in Europe, the way of their diffusion, and their interaction with Neanderthals in terms of coexistence, cohabitation, and competition. Since 2020, Professor Talamo is the director of the Radiocarbon Laboratory Bravo, Bologna Radiocarbon Laboratory devoted to human evolution. Professor Talamo, thank you for being here, and the floor is yours.
Thank you very much, and thank you to everyone attend this today. I will share my screen now. So. It is okay. You can see it.
Yes, it's perfect.
Perfect. Thank you very much. So good afternoon, everyone. It is a great pleasure for me to have the possibility to deliver this talk for this great meeting, and thank you very much for inviting me. It may be a cliche to say that art is a form of symbolic behavior as modern cognition, as old as humankind itself. However, in Europe, there's so far evidence show that artistic behavior, sorry, I have to, because it bothered me, all of the entrance of, and I don't know how to, now, eliminate, because continuously I write people and pop up on my screen. Artistic, so there's so far evidence show that artistic expression, like any kind of personal ornament, is associated with the emergence of cultural innovation introduced by Homo sapiens during the so-called Initial Upper Palaeolithic. As of course demonstrated by the earliest unsophisticated manipulation of animal teeth in Bulgaria around 46,000 years ago. And similar behavior is documented in Southwestern France within the Neanderthal groups. However, the question around the beginning of the artistic explosion and the timing of this behavioral innovation is still challenging. A legitimate question is how confident we are about the emerging hypothesis based on statistically debatable age model. Do we really have such a high chronological resolution to say that those fossils or finds are the oldest or youngest? Do we have a sufficient number of archaeological sites with robust and high resolution chronologies to corroborate our hypothesis? If we look at the time period of the interaction between Neanderthals and Homo sapiens in Europe, the resolution of most of the radiocarbon dates is so low that we could suggest a chronological overlapping between the two species across different regions of circa 2000 years. Simply put, with this chronometric data, is like trying to debate whether everyone here today shook hands with Julius Caesar. And the major challenge of this scientific dare is related to the radiocarbon method and the quality of the archaeological record. Now, radiocarbon is considered the most important and universal dating clock in archaeology for several reasons. The first one is the dating range of the past 55,000 years covered an essential part of human evolution, especially the transition from Neanderthal to Homo sapiens in Eurasia. The carbon is a ubiquitous element in the environment, and organic components recovered in archaeological sites can often be linked directly to human activities. Simply put, radiocarbon is a gift from heaven, since it is created in the atmosphere, is incorporated into all living organisms, and decays over time. Now, this beta-type decade of 5,730 years is the gift of heaven, because this rate of decay is unique. And it is in this way that when we measure the remaining amount of carbon-14 in an organic sample, we can determine the age of death, going back to 55,000 years. Its only weakness, if we want to see in this way, is that the amount of C14 in the atmosphere varies over time. And this doesn't allow us to give a calendar age. To get it, we have to calibrate the radiocarbon age with an independent calendar scale. This is what we call calibration curve. Now, numerous radiocarbon revolutions have occurred since Libby won the Nobel Prize in Chemistry in 1960, to the construction of the calibration curve, to the development of accelerated mass spectrometers, the AMS, to measure C14 in small samples, and the widespread use of Bayesian statistics to analyze and constrain the calendar ranges obtained from the radiocarbon data linked to prior information, such as stratigraphy. Today, the radiocarbon method is even more intertwined with the field of archaeology and is facing a great advance, which by analogy empowers the radiocarbon clock to have the precision of the so-called Swiss chronometer, no longer marking only the minutes and hours, but also marking the seconds of our fascinating evolutionary history. And the first one is regarding the destruction of analyzed sample. We know that sampling for C14 dating is a destructive process, and human fossils or bone artifacts are increasingly rare and precious with the time depth. Today, the sampling for C14 dating is around a minimum of 500 milligrams, not to mention the hydroxyproline method, which goes even up to 2 grams per sample. And let's add to that the fact that once the piece is destroyed, there could be not enough material to get the dating. The good news is our new infrared spectroscopy connecting with a hyperspectral imaging camera. This new technique allows us to find those samples suitable for analysis. In fact, With this technique, we can visualize and quantify the amount of collagen in bones and cut in the right piece, the precise area, in order to saving time, money, and unnecessary waste of valuable material. Therefore, it is easy to imagine that this technique will enable radiocarbon analysis at many sites where previous attempts have been neglected due to poor preservation. The second amelioration is regarding the calibration curve, the one you all use to calibrate your C14 ages to get the calendar dates. Now, for the past 14,000 years, the calibration curve has been based on trees and is highly precise. But for older periods where trees were not measured, the precision of the calibration curve drops dramatically. And the farther we travel into the past, the less accurate the radiocarbon dates become. Now, my ERC project, which is called Resolution, together with the INCAL working group, are working on resolving this issue with the help of new fossil trees and the beryllium 10. Because the production of these two cosmogenic isotopes, C14 and beryllium 10, is synchronous. And thanks to this, we can link the C14 obtained by our new trees to the calendar scale of the beryllium 10 in the Greenland ice cores. And this let us have new segment of calibration intervals of high temporal resolution and high precision. Now, the present state of the Resolution project is the result of an intense collaboration of dendrochronology and radiocarbon studies, based on findings of trees in deposit of glacial and the glacial period. We found new trees in northern Italy and in northern Portugal, where we found an entire submerged forest under the Atlantic Ocean, which is 30,000 years old. And here now, I want to show you a little bit the work we have done in Portugal. A little video, if it starts, let's see. And now, in this way, where we collect all the fossil trees, we establish several chronologies in different time period and obtain high resolution C14 datasets. Last but not least is the C14 error range, the one that makes you shoot hands with Julius Caesar right now. So in the last few years, my team was able, with the coordination between archaeologists, radiocarbon specialists, and physicists behind the AMS machine, to provide a narrow range never seen before that reached at 42,000 years, a C14 error of less than 300 years. In order to show the importance of having a small C14 narrow range when we calibrate the radiocarbon age into the calibration curve, especially for the Middle Upper Paleolithic, I use here 7 direct dates, radiocarbon dates of hominin. So these 4 in blue are from Bachukiro with a very small error range, and these in green are Neanderthals. The error range I showed you before, so very large error range. And as you can see, the comparison between chronometric data with wide and small C14 error ranges show the advantages that the small C14 error could deliver in terms of temporal and environmental precision, especially when we combine it with the climatic events. We can be more sure about one sample in a climatic period compared to another one, instead of having this error range where it passes 2 different climatic situations. Now, the combination of all of these factors increases the complexity in the nature of the data. And this means that archaeologists need to have a critical understanding of what kind of C14 results they take into account in order to build an accurate and robust chronology for an archaeological site, especially in the Middle Upper Paleolithic. As you may understand, radiocarbon is part of those applied science that never stop being improved to be revolutionized in some way. However, it is not always straightforward to make use of these substantial advances, because it depends much on the question you ask, your expectation. Do you want to open a simple door, or do you want to open a gate? Then let's open the gate of creative innovation, starting by Neanderthal, using the radiocarbon dating method. In order to understand the situation, we have to remember that Neanderthals populated Europe for 400,000 years. And for 200,000 years, they shaped the same tools, called Middle Paleolithic. But suddenly they changed it. And where, when, and especially why? In France, in 1950, Leroy-Gourand excavated a site called Arcy-sous-Cour, and he discovered something new. The appearance of another strange lithic industry, which has nothing to do with the Middle Paleolithic, but is completely different. Moreover, he discovered also some jewelry in the same layer where these new tools appear. And he called this industry Châtel-Perron, because the Arcy-sous-Cour is in the Châtel-Perronian region. And he also discovered quite a lot of human teeth. Many of them were attributed to Neanderthals because of the diagnostic traits were really diagnostic on Neanderthal, but some of them were not diagnostic, so they cannot attribute it to Homo sapiens or Neanderthals. But let's say mostly of these teeth were definitely Neanderthals. So the Châtel-Perronian is thought to be made by Neanderthals. But how strange it is, since the Neanderthal is so monotonous. So if it is really him making this in France, the question arises, why does he start changing? It is all in his own invention, idea, or has he seen someone else around and try to copy him? Between 2012 and 2016, we started to get answers. So first of all, we dated the Châtel-Perronian layers at RC-Surcourt using accurate dates. And we find out that Châtel-Perronian is ranging between 44,500 to 40,200. Then we have a great possibility to directly date a piece of Neanderthal that was found in the Châtel-Perronian layer, but in another site, which is called Saint-Césaire, close to RC, but still is another site. And this data resulted in calendar age of 42,200 to 39,900. And then arrived the cherry on top of the cake, where we found at RC a new fossil, which was investigated by the ancient DNA, and they found that this fossil is actually a Neanderthal, a child of Neanderthal. And then, of course, we have definitely to date it to understand that it's belonged to the Châtel-Perronian layer. And the age that came out was between 42,000 to 40,700. So all of these ages are chronologically contemporary. And now we can say that the Châtel-Perron is made by Neanderthal starting from 44,500 years ago. But still, why they change, why they shape their tool in a different way? The question was still open until the Homo sapiens from Bachukiro was discovered and directly dated. So Bachukiro is a site in Bulgaria and excavated for the first time in 1938 by Dorothy Garrow. And we started to re-excavate the site with Max Planck in 2015. And during the excavation, of course, we found other Homo sapiens bones. And of course, we have to date it. And now the direct dates show that they were the earliest Homo sapiens found and directly dated in Europe. And the age was around 46,000 years ago. This group produced an industry called Initial Upper Palaeolithic. And as I showed you at the beginning, they also produced the earliest unsophisticated manipulation of animal teeth. Now, if we compare the Homo sapiens jewelry made in Bulgaria at 46,000 with the Châtel-Perronian made by Neanderthal in France 2,000 years later, we discover the similarity. So the answer to the question why they changed it, did we influence their culture? Well, the answer is yes, we influenced them, or maybe we inspired them. Or let's face the reality, they copy us, and which is typical from human species. Then it's perfectly understandable why we invented the copyright. Now we understand why the creative innovation by Neanderthals probably began, but these were unsophisticated jewelry. We are more creative than that. We, Homo sapiens, used to make many more things. And we began to use ivory from mammoth tusk for the production of sophisticated things. But if Bachukiro at 46,000 years old made simple jewelry, when do we start making complicated things, and especially where? Now, in Germany, in the Swabian Jura, many ornaments, unique artistic pieces are found, pendants and figurines, and sometimes they used to decorate them with geometric patterns. In addition to line, crosses, and hashtag, a new type of decoration, the alignment of dots, appear in some ornaments found in southern West France and in Siberia as well. However, most of these ornaments were discovered during archaeological excavation carried out in the early 90s, so their chronological attribution remained imprecise. After some restudy of the excavation in Germany, these ornaments are indirectly assigned to an uncertain time period, older in any case than 40,000 years. And in other regions, the indirect chronological attribution were younger than the one of Germany. So this implied that from Germany, the artistic behavior began and spread. And this is what's called during the period of Aurignacian time. But I would like to underline one more time that this situation is created because no one of these fossils were directly dated. This means that the chronological reconstruction of the appearance and spread of arts and ornaments in Europe remains highly debated. Now, in 2012, I came across a site in Poland called Stania, and I was invited to establish the chronology of the site. And when I was there, they showed me this. A wonderful ivory pendant with a punctate decorative motif together with an oval. Now, the pendant was found already in 2010 during archaeological investigation conducted by the Polish team, along with animal bones and some stone tool from the Upper Paleolithic period, so from Homo sapiens. But in the cave, there were traces of both Neanderthals and sapiens. And what we discovered is they were there just for sporadic visits. It was probably during one of such a visit, perhaps a hunting expedition to the nearby Krakow plateau, that the pendant broke and was abandoned in the cave. And more than 40,000 years later, the archaeologists unearthed it and discovered it for our pleasure. Now I want to show you this. This jewelry shows the great creativity and extraordinary manual skills of Homo sapiens group that occupied the site. The thickness of the jewelry is about 3.7 millimeters and showed amazing precision in engraving the dots and the two ovals for wearing it. Now, whether these marks indicate a lunar calendar or a count of prey hunted remains still to be discovered. We are working on it. Now, however, the analysis and dating of this 41,500 years old ornate piece of jewelry now allow us to expand our knowledge about the timing of the appearance of these objects in Europe. In fact, the territory of Poland was often excluded from hypotheses regarding the first expansion of Homo sapiens into Europe, suggesting that this region remained desert for several millennia after the disappearance of Neanderthals. The age of the ivory pendant found in Stania cave finally proves that the migration of sapiens in Poland is as old as those in Central and Western Europe. This important finding will change our perspectives on the adaptability of these early sapiens groups. And once we put this data in a model, it is easy to see that they are the oldest dates compared to the other side where the other ornaments were found. And just to remember, all of them are not directly dated. This situation now challenged the monocentric model of diffusion of artistic innovation in the Aurignacian time period, since it is easy and fascinating to see that similar decorations appear independently from one part of Europe to another. To conclude, these studies teach us that if we want to seriously solve the debate on when we interacted with Neanderthal, when we crossed different regions, land, environments, or when the mobility art emerged in Paleolithic groups, we need to use the advanced radiocarbon method. And importantly, we need to directly date objects or human bones, especially those found during past field work or in a complex stratigraphic sequence too. And only in this way, we can open the human evolution gate. So thank you very much for your attention. And I leave the floor to Diego.
Okay. Thank you very much, Professor Talamo, for your great presentation. It was very interesting. And so before going to the Q&A session, I just want to invite all of you to the next lecture of this series that will be presented by Veronica Teixeira, entitled Series, a Powerful Tool to Study Ancient Materials with Synchrotron Light. It will be on February 16th at 3 p.m. Rome time.